Hello class, this is 3 and 4 from your hard problem set. So 3, a water balloon is dropped from the top of the 200-meter high tower. The green arrow at the base of the tower sees the balloon being dropped and then shoots an arrow at 40 meters per second straight up towards the balloon. How far has the balloon fallen when it is struck by the arrow? So again, you're going to want a really good picture for these. Do not worry about this. So we have a balloon. It's obvious it was dropped, so its initial velocity is 0 meters per second. We have a green arrow going up at 40 meters per second. We know that since both of them are in the air at this point, both of their accelerations are going to be negative 10 meters per second, with the idea that down is negative, up is positive. The balloon is at a 200-meter tall tower. The arrow originates from the ground. I haven't told you how tall the green arrow is, so don't worry about it. Let's just call that 0. And now we have to figure out where do these two meet. So what's the x for A, which is also the same thing for A, my arrow, how far it goes up, and for x, for the balloon, B. They're going to be the same spot. It's where they meet. Alright, so we know that therefore if that's where they meet, the time for them must also be the same. So this is going to be a bit like the kitten problem, except there will be acceleration in it. So go ahead, this is the picture. If you haven't yet already tried the problem, figure out which two equations you need, and go on. Alright, also we pretty much have all of our variables written, so let's try writing our equation. You are going to want x equals x naught plus 1/2, don't forget our velocity, plus velocity t plus 1/2 a t squared. So for both of these things, so it's going to end up being different. For the xa, we have x naught is 200, but its initial velocity is 0, so we're not going to include the initial velocity, plus the 1/2, and we're going to have acceleration is negative 10 t squared. For xb, you're going to have no initial position. The initial position is 0, so we're just going to go ahead and talk about its velocity, which is 40 meters per second times t, plus 1/2 negative 10 t squared. And we already talked about earlier that these two things must be equal. That means these two equations must be equal. So you want to set them equal to each other so you can cross out this as a variable. So you have 200 meters plus 1/2 times negative 10 t squared is equal to 40 meters per second times t plus 1/2 negative 10 t squared. Alright, let's simplify things a bit. So negative 10 divided times 1/2 is a negative 5t. So you have 200 meters minus 5t. And you have 40 meters per second times t minus, again, this is a 5t squared. Oops, almost round my squared there. Alright, so we want to get all the t's on the same side. So it's negative here, so you're going to want to add it to both sides. And then you notice something. Hey, wait. I have a negative 5t squared, and then I have a positive 5t squared. If I have the same amount of negative and positive things, this is all going to equal 0. So that simplifies your equation greatly. You now have 200 meters is equal to 40 meters per second t. Now we need to solve for t. We do 40 meters per second. This is going to give you t equals 5 seconds. So this is how long it takes before they hit each other. How far do they actually go? And in fact, you care about the balloon. So we want to plug it into the balloon equation. I'm gonna get rid of this work here, leaving our time that we got. So plug this time into your balloon equation. Your balloon equation is xb, and I switched to these. Oops, this is xb. This is xa. xb, it starts at 200 meters, and you're adding it to your negative 1/2 acceleration times t squared, or 5 squared. Square your 5, you get 25. Half your negative 10, you get negative 5. Let's do 100 meters. Then you figure out 5 times 25 gives you a negative 125. And you can really stop here because this is how far it fell. But you can keep going, and essentially you're going to get 75 out of this. So 75 is where your balloon ended. It fell down to the 75 mark. So total distance it fell was 125 meters. If this was your problem, if you got this far and wrote this, I would pretty much give you all the points. Hopefully this is helpful. Again, if you need more help on these, which is completely understandable, do come see me in person outside of class. I am available as much as possible. Just talk to me. Alright, go ahead and try the next one, Spider-Man problem. So read the problem. Spider-Man is 50 meters above the Green Goblin and Gwen Stacy. When the Green Goblin throws Gwen Stacy down, anyone remember the movie? Alright, I guess he technically drops her, but Gwen is 200 meters above the ground. Spider-Man begins downward accelerating from rest at a rate of 20 meters per second squared. If Gwen is originally thrown at 30 meters per second, does Spider-Man save her in time? Alright, let's see. First, this one requires a really good picture. Like, really. So we're going to have Spider-Man up here. Although he's probably not happy right now. He's 50 meters above the Green Goblin. Who's essentially holding Gwen Stacy. Help me, Spider-Man. Alright. Or they are an additional 200 meters above the ground. And remember, Gwen gets thrown at 30 meters per second. So let's establish that up is positive, down is negative, so she gets thrown at a negative meters per second. He's accelerating downward, so again, negative at 20 meters per second squared. Right? He's accelerating down. He's starting it from rest, so he was not going anything in the beginning. He was just standing there. So we keep going. So these are the things we know, so let's start writing them out more explicitly. So there's going to essentially be a Spider-Man problem and a Gwen problem. Basically, we gotta figure out who gets down to the bottom first. If Spider-Man can get down to the bottom, he can catch her. If Gwen gets down to the bottom, it's over for Gwen. So we gotta figure out really time. This is our big question. So let's lay out things for Spider-Man. So Spider-Man's initial position, he's really high off the ground. So, really high off the ground. He's 200 meters plus another 50 meters. So his original position is 250 meters off the ground. His final position, right, he has to go to the ground to try to save her. I mean, we could try to calculate if he saves her, where exactly does he save her, but it's easier just to figure out who gets down there first, therefore, can he save her in time? So he has to get to the bottom. Alright, his initial velocity is 0 because he started from rest. His acceleration, however, he's accelerating pretty quickly, quite quickly in fact, at 20 meters per second. But remember, this is down, so it is a negative. Alright, and we want to find time. For Gwen, she has x naught of 200. She's up there with the Green Goblin. Alright, again, her final would be the ground, but for her that doesn't mean saving. That means it's over if she gets to the ground before Spider-Man. Her initial velocity is negative 30 meters per second. And her acceleration, because she's falling, so we're not going to talk about terminal, well, we will talk a little bit about terminal velocity, but you will not do any equations relating to any air resistance. So she is accelerating at the rate of gravity, acceleration due to gravity. So she is accelerating. So she's really not in a good place. And again, we want to figure out how much time. So really what you should do is take each of these and solve them separately. Hopefully you can look at these and be like, aha, I want our first and main equation. Hopefully you've kind of started accidentally memorizing it, because I'm not going to ever require you to, but you probably started to realize what it should look like. Alright, try that. Try solving it, and then we'll move on. So you need to solve for Superman, or Spider-Man's time. I'm going to see if I can fit it on this paper. So the final position is the floor, because that's where he's trying to go. Initial position is 250. Initial velocity is 0, so you can get rid of that term. And then you have his acceleration is 1/2, negative 20, because it's in the downward direction, t squared. So you are solving for t here. Move your 250 to the other side, so it's negative. Simplify 1/2 times negative 20 gives you negative 10. T squared. Divide by that negative 10, so you're going to get 25 is equal to t squared. Square root both sides, and t will equal 5 seconds. So from this point, there's two ways to go about figuring out if Gwen hits the floor before Spider-Man can save her. You can either plug in this time, and then find her new position given this time. If her position is above 0 or above ground, he's able to get to her before she hits. If her position is below ground, that means she already hit, and means that she did not manage to be saved by Spider-Man. I will do both ways, just to show you how you would do both. And then the other one is, again, solve for Gwen's time, how long it takes her to get to the ground. So I'm going to erase this. We know that t equals 5 for Spider-Man. And then let's solve for Gwen's time, and then I'll show you what I think is an easier method. So going on to find the time for Gwen, and then I'll show you the mathematically easier way to do it. So for Gwen, her equation looks like this. 0 equals 200 meters plus that negative 30 velocity she started with times time, plus that 1/2 negative 10, our acceleration times time squared. I'm going to simplify this. 0 is equal to 200 minus 30t minus 5t squared. So the only way to really do this well is to factor it. So I know factoring is definitely in the realm of more like algebra 2, I believe, is when you guys do factoring. But what you'd want to do is, this negative 5 next to your t squared is making this really confusing. So you actually want to divide out your negative 5. If you divide out negative 5 from 200, you get negative 40. You divide negative 5 out from 6, you get, from 30, you get 6, and then t squared. So it's going to look something like 0 is equal to negative 5 t squared plus 6t minus 40. So hopefully that looks a little more like something you've done before. So depending on how you get taught, I know some are done with the diamond method, I think it's called. I'm not as familiar with this one, but I think it has something to do with the fact that you have to find something that multiplies by negative 40 and adds up to 6. You know one of them has to be negative. It's the only way. And the 6 is positive, so if it's adding, the small number has to be negative. So if you have 10 minus 4, that gets you 6 times each other, you get negative 40. So this factors out to t minus 4 and t plus 10. So t can equal either a positive 4, because this has to equal 0, either a positive 4 or a negative 10. And hopefully your knowledge of time knows, wait, Gwen didn't go back in time 10 seconds, so this one's impossible. So the time for Gwen is 4, which is definitely less than 5, so Gwen does hit the ground first. A way to do this without factoring, however, is, again, let me erase all this, is instead of figuring out how long it takes her, we can say, well, Spider-Man gets there first. Well, Spider-Man gets there at 5. So when Spider-Man gets there, is Gwen above ground or below ground? So basically you're going to say, well, we're going to make this 5, and this, where is she when he can finally have a chance to save her? So you would solve it exactly the same way, except now you just plug in all your variables. So 30 times 5 plus 1/2 negative 10, 5 squared. Let me simplify again, so, I'm sorry, we don't know this. 200 minus 5 times 30 gives you 15 minus 1/2 times 10 is 5 times 5 squared. So we can do the 200 minus 150, so we get 50 minus 5 times 25, which gives you negative 125. Hopefully you can see by now that this number is going to be very largely negative, which, right, I called the ground 0. If she's below ground, she already hit, she's going to be buried 6 feet under. So Gwen did die in this problem. I'll admit to never being a huge fan of Gwen Stacy as a character. Alright, anyway, hopefully this helped you. Do go ahead and practice these on your own. We'll have a practice test coming out. Remember, test is next Wednesday. Prepare for it. We will do some review on Tuesday.